Alright, so in this video we go over section 7.3, which is integration using tables of integrals. So most of the times there will be no method right away that we can use to integrate a given function or to evaluate a certain integral, which this gives rise to going towards another alternative called using a table with formulas, full of formulas in which all we do is compare our given integral with a suitable formula, and then we just plug in the numbers or whatever expression, and then we're done with the integration. However, all these formulas come from other techniques that are not covered in this course, and that give rise to a lot of integrals that come in a table. Okay, so let's observe example A, the integral of 1 over x times 3x plus 4. So if you attempt some kind of a substitution or any other method, you will find out that it's not going to work. Lucky for us, there's this formula sheet that we have from the textbook that I uploaded to the files. So let's see. To me it looks like form number 10, 1 over b. We need to identify a and b for this form, and we are going to apply this formula. So I'm going to write it. First I'm going to identify it here, and then I'm going to write it as well. So in this case we have a equals 3 and b equals 4. So using that form, we have the integral of x times ax plus b, whose result will be the following: 1 over b ln of absolute value of x over ax plus b plus c. So that's the form that we are going to use. Let's just adapt it to our numbers in this case. Okay, so all we do is 1 over b, which is 1 over 4 or 1/4 ln of absolute value of x divided by ax plus b, which is 3x plus b, which in this case is 4. And that's about it. No need to create a substitution, no need to create anything else. Okay, so let me again state that this is formula 10. All right. Formula number 10. Okay, let's look at letter B. Okay, if we looking at letter B, let me compare with anything from this page of the table. Nothing seems right away to suit this part of the table. Let me look at the other page then. And to me it looks like number 16. 16 is the one. Some x squared minus some quantity squared, and we get this result. Okay, so I'm going to, in this case, all we need is to identify a, but be careful because we have the number 25. So our job first of all is to rewrite the integral. I'm going to take the 9 outside of the integral. Dx over x squared minus 5 squared. This will tell us that a equals 5. So the formula I'm going to use is squared minus a squared in the denominator equals 1 over 2a ln of x minus a x plus a plus c. Alright, so all we do is in this case keep in mind the 9. Inside of the brackets I'm going to write down the result of 1 over 2 times a, which in this case a is rather 5, not a, ln of x, absolute value of x, minus a, which is minus 5, over x plus 5. close the parentheses, plus c. We're almost done. Let's clean this up. 9 times 1 is 9. 2 times 5 is 10. 9 tenths. ln of the absolute value of x minus 5 divided by x plus 5. Alright. Let's look at another example. Letter C. If you attempt to do some kind of substitution, that's essentially not going to work. By the way, over here I'm missing a dx. Let me write it down by hand. Alright. So, in this case, let's find a suitable formula. In this case, looking at the formula sheet, it looks to me like formula 21 that seems to be there. Okay, so we need to identify, in this case, 3 things. Number 1, we need to identify an a, which in this case is the number 2, a b, which is the number 7, and a k, which is the number 5. Let me write down the formula just for your reference. So the integral of this form, a plus b e to the kx over that dx equals x over a minus 1 over a k ln of the same expression, absolute value of the expression a plus b e to the kx plus c. Okay, so that's the formula that we are going to use. So in this case, let me recall, this was number 16, this is number 21. Okay, so all we do is just plug in the numbers in this form, x over a. So this will be equal to x over a, which is 2, or 1/2 x, that's the same, minus 1 over a times k, in this case 2 times 5, which is 10, ln of the same denominator of the integrand, 2 plus 7, e to the 5x, don't forget absolute value bars, plus c. And that's final answer to this. Right? So these first 3 examples gives us an overview on how to look at an integral and how to compare with something in our formula sheet. The next example will steer us into some sort of a different direction. In this case, to look for a reduction formula. If you look at this form, it might look familiar already from the previous section, integration by parts. Okay, so let me write that down. Integration by parts. However, 3 times. Okay, that's an alternative to evaluate this integral. Again, this x to the n tells us how many times do we perform the integration. However, there is an alternative to avoid all that setup, and we do that by looking at a reduction formula. In this case, let's go back to the integral right here, to the integral sheet, and it looks like formula number 20. Okay, x to the n e to the kx. We're gonna do this a few times. I'm gonna show you how to do that. Nonetheless, I don't think it's going to save a lot of time in comparison with integration by parts. However, that's another alternative. First of all, let me write whatever it's. In this case, I need to identify n equals 3 and k equals 2. And I'm going to write down the formula. Integral of x to the n e to the k x dx equals x to the n e to the kx divided by k minus the integral minus n over k integral of x to the n minus 1 e to the kx dx. So that's the formula that we are going to use. This way I don't have to put the page every time. Okay, so let's go ahead and do that. X to the n e to the kx. This is going to be the same as x cubed e to the 2x divided by k, which in this case is 2, minus n over k, where n is 3 and k is 2, 3 halves, the integral of n minus 1, where n is 3, x to the 3 minus 1, e to the 2x dx. Alright, let me do some simplification here. Maybe you might want to write this division by 2 as a 1/2. Okay, I'm gonna go over here. It's gonna be 1/2 x cubed e to the 2x minus 3 halves times the integral of x squared e to the 2x dx. Alright, I'm going to focus on the integral right here, in which now I have n equals to 2 and k still the same, the number 2. And I'm going to use this formula a second time. So I'm going to have 1/2 x cubed e to the 2x minus 3 halves times whatever we get from using this formula again, x to the n, which is x squared e to the 2x, divided by k, which in this case is the number 2, minus the integral, rather n over k. Alright, it's n over k, in this case is 2 over 2. I was not going to write because this was going to reduce to 1, and which we don't need to write. But in this case, the reason I'm writing is just so you can see where is this coming from, so we can honor the n over k process that comes from the formula. So we are going to have x to the n, which is 2, minus 1, in accordance with the formula right here, e to the kx, which is 2x dx. Okay, before distributing and whatnot, let's simplify a little bit here. So I'm going to have 1/2 x cubed e to the 2x minus 3 halves times 1/2 x squared e to the 2x minus 2 over 2, which reduces to 1, and x to the 2 minus 1, which reduces to x to the first. We don't need to write that one, e to the 2x dx. So the next thing we will do here is distribute, but be careful with the signs here. Alright, so this is 1/2. We just keep writing this. That's actually 3/4, not 3/2. X squared e to the 2x. Negative times negative is positive, 3/2. The integral of x e to the 2x dx. Alright, now if we focus on this integral, that requires again to use this formula a third time. Okay, so in this case we have n equals 1 and k still equal to 2. So I'm going to write 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 3/2, whatever we get from using this formula again. So x to the n e to the kx, in this case is x to the 1 e to the 2x over k, which is 2, minus the integral of x to the n, which is 1, minus 1 e to the 2x something interesting is going to happen here. Alright, because this is going to be x to the 0. That's 1/2 x cubed e to the 2x. Maybe you can do this in your head and just erase the x, but I'm going to write everything just so you can see where is everything coming from and how is becoming the final answer essentially. So this will be plus 3/2, 1/2 x e to the 2x, and then minus x, the integral of x to the 0 e to the 2x dx. But what is x to the 0? Doesn't that become just a 1, and then 1 times e to the 2x is simply the integral of e to the 2x? That's all it is. So 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x. I'm going to start distributing this. It's going to be plus 3/4 x e to the 2x minus 3/2 times the integral of e to the 2x. And this one we don't need a formula. Well, if you will, it's a really simple formula. Just divide by 1/2 and keep the e to the 2x. 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 3/4 x e to the 2x minus 3/2 times the integral of e to the 2x, which is itself e to the 2x, times 1/8, which is in this case 1/2, plus c. Multiplying these two fractions together, we get finally the final answer. So every time we stop using the integral sign, we add the plus c. Keep that in mind. 3/4 x squared e to the 2x plus 3/4 to the 2x minus 3/4 e to the 2x plus c. Final answer to this guy, right? So this is the end of this video of this section. I'll see you in the next section.